Hello, dear students. This is your professor Lázaro Pino, and today we are going to see chapter 7, reactions in aqueous solutions. Well, here in this figure, you can see what we call a lamp test. Here we have two electrodes that conduct electricity in a circuit where we have a bulb. When we introduce the electrodes into the solution, and the solution is non-electrolyte, it means that the liquid is made of molecules, no current flows, and the bulb is not light. Then molecules don't conduct electricity. But what happens if we have a few ions? Then if we have a few ions, there will be some light in the bulb. Why? Because the ions in solution will conduct electricity, but not all the liquid has ions. There are a lot of molecules, so the conduction of electricity is not so very good. This is the case of a weak electrolyte. But if the solution is ionized almost completely, then we can find a lot of ions in solution, and the conduction of electricity is pretty good. So the bulb is very, very light. This is a way that we can use to recognize a non-electrolyte from a strong electrolyte. Let's see, here we have sodium chloride and calcium chloride. Both are ionic solutions, compounds. Ionic compounds. They are made of cations that are positive ions and anions that are negative ions. When we put this compound into water, the water molecules that are dipoles will surround the cation and the anion, and then the cation this way will be taken into solution, and the same thing with the anion, surrounded by water molecules. This is the process of dissolution of an ionic salt. Let's see what are the solubility rules. Well, all nitrates are soluble. All ammonium or alkali metals like lithium, sodium, potassium, rubidium, cesium, francium make soluble compounds. All carbonates, phosphates, and hydroxates are insoluble, except when the cations are the ones in group 2. Rule number 4, all chlorides, bromides, and iodides are soluble except with silver cation, lead 2, or mercury +1. All sulfates are soluble except with calcium sulfate, strontium sulfate, barium co-sulfate, radium sulfate, and lead 2 sulfate are not soluble, are not soluble. Well, based on all these rules, we can see this anion and this cation, and we can say if they make a soluble compound or not. Well, chlorides, let's see, all chlorides are soluble except for these cations. Oh, this is not the case. Then we can say that this compound is soluble. Let's see this one. Well, we can see that phosphates are insoluble except for these cations, and barium is not in this group. So this compound is insoluble. Here we have silver and chloride. All chlorides are soluble except for, oh, look at here. Silver is here. So this compound is insoluble. Sorry, I put here soluble, but is insoluble. Okay? Insoluble. Then every time we put this compound in solution, we are going to have a solid. Let's continue. Look at this, sodium and nitrate. All nitrates are soluble and sodium is in this group. So this compound is soluble for sure. Here you have the combination of different compounds, sulfur and lead. Let's see, all sulfides are insoluble except for sodium, potassium, etc. So this compound is insoluble because it's not in the group of the soluble ones. Chloride. Chloride, all chlorides are soluble except for, look, lead-2 is in this group. Then this compound is insoluble. Nitrate, all nitrates are soluble. Well, soluble. This is the compound that is soluble. You can see that this combination also produced an insoluble compound, and here two cations, there is no reaction at all. A solution of sodium phosphate reacts with a solution of lead-2 nitrate. Then we have two compounds. What we do in this case? Well, we put the cation in the first compound with the anion in the second one, and we get this compound. If you go to the solubility rules, you can see that this compound is insoluble. And then you take the cation in the second compound and you combine with the anion in the first one, and they make sodium nitrate that you know that is soluble, because all the salts of sodium and all the nitrates are soluble. So in this compound, in this reaction, we get a solid. It's a precipitate because this compound is insoluble. Here you have different anions and different cations. I put them into this table, and I began combining this with this, and we get a soluble compound. This with this makes a soluble compound, and the same with silver. But what happened with chlorides? Well, chloride and lead-2 and chloride and silver produce insoluble compounds. In the case of chloride and potassium, well, they are soluble. And so you can continue, you can stop the video, and you will see at the end that there are 5 different compounds that are insoluble. 1, 2, 3, 4, 5. And here are their formulas. How can you do this? Using the solubility rules. Well, let's see what is a molecular equation. The molecular equation is the one when you have one compound reacting with the second one, and they combine in the way I told you before to make 2 new compounds. Here is important that you put the subscript indicating the state of the compound. In this case, this is aqueous, but this is a solid, this is aqueous, and this is aqueous. All right. The ionic equation is when you divide the compounds into ions. Here you have 2 potassium positive, and here you have the chromate ion. Here you have barium. Barium has 2 positive, and nitrate, well, you have 2 nitrate, as you can see, because there is a 2 a subscript of the nitrate ion. Arrow, and then you get a solid. Well, the solid remains without being in ionic forms, because it is not a soluble compound, then it remains as a solid. You don't divide it into ions. And in the other hand, you have that potassium and nitrate are ions. Now, what you're supposed to do? Well, you have to look for the spectators ions. The spectator ions are the same one, the ones that you have the same one side than in the other side. And as you do as if you were in a math equation, you cancel the same ones in both sides of the equation. The same thing with nitrate and nitrate. What remains then? Remains barium and chromate. And barium chromate in the products. This is what we call the net ionic equation. The net ionic equation. Remember, you don't write the spectators because they do nothing in the reaction. The only ones that make a change are barium and chromate that produce a solid. This is a very important exercise you're going to have in the homework in mastery, a lot of these exercises. So try to practice a lot this procedure. Begin by the molecular equation, then the ionic equation. You cancel the spectators, and you get the net ionic equation. Let's continue. Here we have a complete example of what I was telling you. Here we have the molecular equation. You have the complete ionic equation. And here you have the net ionic equation. Okay? Now let's go to the following one. And here we have a new concept, acids and bases. What is an acid and what is a base according with Arrhenius? A strong acid is a strong electrolyte that produces the hydrogen ion or hydronium. It's also known as hydronium. Then every time you dissolve an acid and this acid is strong, they produce the hydronium or hydrogen cation. This is the concept of a strong acid. Then we can say that the strong acids behave as strong electrolytes, the same way we have seen with salts at the beginning of this lecture. Well, what is a strong base? Is that one that in solution produce the hydroxide ion, hydroxide. This is the concept for a strong base. Then, in general, for the reaction between an acid and a base, the result will be, the net ionic equation will be this one. The combination of a hydronium ion with the hydroxide ion to produce water. This is the net ionic equation in the case of the reaction between an acid and a base. Here is a summary of strong acids and strong bases. Here you can stop the video and you can read this concept because it's very, very important for you. Then the net ionic equation between a strong acid and a strong base is that one that produces water. Okay? In the reaction of a strong acid and a strong base, one product always will be the water. This reaction is also known as neutralization. Well, the net ionic equation for the reaction between this, that is a strong acid, and this, that is a strong base, of course, will be this one, where water is produced. Let's see what is the oxidation reduction reaction. Well, every time a compound, let's see, I'm going to put X, loses electrons, here we have, we'll get a positive charge because we'll lose an electron. In this case, we say that the process is oxidation. Why? Because electrons are lost. Oxidation. Because electrons are lost, and as you can see, the oxidation number of an atom is considered 0, and it goes from 0 to +1. There is an increase in the oxidation number. Then every time there is an increase in the oxidation number of an element and some electrons are lost, we say that we are in front of oxidation. In order that we have oxidation, we need reduction. And then it will be another atom that is in the atomic form and will gain that one electron, and then we'll make an anion or will reduce the oxidation number. Then reduction is when electrons are gained and the oxidation number is reduced. Every time we have a reaction between a metal and a non-metal, there will be a transfer of electrons. And so we can say that this is an oxidation reduction reaction. Remember, a metal and a non-metal always will have a redox reaction. Well, here you have aluminum, in this case, is losing 3 electrons, and iron 2 is gaining. So this is a redox reaction. Aluminum loses 3 electrons, iron gains 3 electrons. Iron is in this compound, that is iron 3 oxide. Well, the other process that is important for us is the formation of a gas. The result of a reaction is always a gas released. For example, when we have a metal and an acid, always, hydrogen will be released. Then the reaction between a metal and a strong acid, a strong or weak acid, one of the products will be hydrogen. Hydrogen is a gas. This is another type of reaction. The other one is the combustion reaction, where an organic compound combines with oxygen to produce carbon dioxide and water. I'm not going to speak so much about this because in the last lecture, I explained how to balance this type of equation, and I explained many things about combustion reactions. Well, in generally, we can say that the chemical reactions can be divided into precipitation reaction, acid-base reactions, or redox reaction, oxidation reduction. The oxidation reduction can be divided into combustion reactions. Synthesis is done when we join together two compounds or two elements to give only one. And decomposition, that is the opposite. AB will be decomposed into A and B. Then here we have a general explanation of the different types of reaction, chemical reactions. Here you have a question. The reaction between hydrogen and oxygen to form water can be classified as oxidation reduction reaction. Well, yes, hydrogen loses electrons and is transformed into positive ions. And oxygen from 0, that is an element, is considered the oxidation number of an element is considered 0, gains the electron from hydrogen to make the oxygen -2. Then this can be considered an oxidation reduction reaction. Yes. It's a synthesis reaction. Yes, because two elements combine to give a compound. Then it's also a synthesis reaction. It's a combustion reaction. Yes, because is one compound combining with oxygen to produce an oxide. In this case, water. Then we can say that the answer is all of above is correct. Well, thank you very much. That's all for today. If you have any questions, don't hesitate and ask me.